We have here an angle and two sides of a triangle given, and one of the sides is opposite that angle. And so this is the configuration side-side angle, which is the ambiguous case of the law of sines. Let's draw a picture of what we have. We have this angle of 49 degrees, which is going to look something like that. Doesn't really matter. It's perfect. It's just that's an acute angle, and that's what's important that we draw. And the side that's adjacent to it is the A, which is 28. And the side opposite that angle B is this side B, which is 26. And because it's shorter than the 28, it might be too short and not connect at all, or it might be long enough to connect in a couple different places. Okay, or it may be just barely long enough to touch in exactly one place and create a right triangle. So we're going to have to figure out what's going on there. We're going to let me first label things here. I've got my angle B, my side 28, and my side 26. Because we have side-side angle, this is the law of sines, and we're going to start by finding the angle that is opposite that side of 28. So our law of sines is the sine of A over A equals the sine of B over B equals sine of C over C. Now this angle over here is going to be angle A. This side length is C, and that angle is C. Now plugging in what we know, we've got our sine of A over side length A, which is 28, and then sine of angle B, which is 49 degrees, over side length B, which is 26. And we don't know either of the C's, so we're just going to leave that like that. Now we have this fraction where we know everything. So we're going to have to use that to find other things. We don't know either one of the C's, so we can't work with this fraction yet. However, over here with the A fraction, there's only one thing we don't know. So we're going to work with this equality right here. That gives us, if we multiply both sides here by 28, we get sine of A equals 28 sine of 49 degrees over 26. And then to get A, the angle A, we will do the inverse sine of that fraction. So let's go ahead and plug that into our calculator. We've got the inverse sine of 28 sine of 49 over 26. And I do make sure that I'm in degree mode here since I'm working with degrees. And when I go ahead and hit enter here, I get the angle A in degrees. And I'll go ahead and round to one decimal place here. So about 54.4 degrees. 54.4 degrees. Now, because I got an acute angle here, okay, I found this angle right here. But because it's an acute angle in the ambiguous case, I know that I can get a second triangle here if I use this position of that side B. To get that second answer, I'm going to use the supplement of this angle that I got. So I'm going to put a subscript of 1 here, because this is for my first solution. For my second solution, I just do 180 degrees minus that angle that I got, 54.4 degrees. And that's 125.6 degrees. All right, now I'm going to go ahead and work through this first solution. I have that angle A now, and so I can get my third angle C, and I'm going to call it C1 since it's my angle C for the first solution. And I know those two angles A and B now, so I do 180 degrees minus the two angles 49 degrees and the 54.4 degrees. And I'm going to go ahead and just plug that into my calculator. 80 minus 49 minus 54.4. And we get 76.6. 76.6 degrees. Now that I have that angle C, I can go back and plug it into my law of sines. And I'm going to do that. I'm going to use this equation now to solve for the side length C. And I'm actually, because I'm solving for the side, I'm actually going to flip those fractions and do 26 over sine of 49 degrees equals C over the sine of the angle C. 76.6 degrees. And now to solve for C, we multiply both sides by that sine of 76.6. So 26 sine of 76.6 degrees over sine of 49 degrees is going to be equal to C. And I'm going to go ahead and plug that now into my calculator. You do want to be careful because we have been using here an approximation, that 54.4. And if you want to be very careful, we can actually use the non-approximated form in that sign. So I'm going to do that. First, I'm just going to come up. I'm going to do 180 minus 49, and then minus that not rounded form, and then hit enter, and that's the angle I'm going to use in this. So I've got 26 sine of that number, and then divided by the sine of 49. Okay, and now I get my side C about 33.5. And I should put a subscript on that as well. 33.5. All right, so I've got my solution now for my first triangle. I've got my third side and those two angles. The second solution, we're going to follow pretty much the same process that we did right here, but now our angle is different. So to get our third angle, C2, C, which I'm doing a subscript of 2 because it's our second solution, we do 180 degrees minus the two angles that we know. And we know the angle B, 49 degrees, and this angle A, so 125.6 degrees. And so we're going to go ahead and plug that into our calculator. Now I'm going to, again, use the non-rounded form to figure out what that is. So it was 180 minus that angle up there. And that is, so instead of using 125.6, I'll use my non-rounded form. So now 180 minus 49 minus that angle there. And that gives us our angle, C, which is about 5.4. I'm just going to write that here, 5.4, but remember that when I actually use it in a calculation, I'm going to use the non-rounded form. Now I go back to this equality here so I can solve for C, and again I'm going to flip those fractions. So I've got 26 over sine of 49 degrees equals C over sine of that angle C, 5.4 degrees. And so multiplying by the sine of 5.4, I have 26 sine of 5.4 degrees over sine of 49 degrees equals C. And now I can plug this into my calculator. Again, I'm going to use the non-rounded form here. 26 sine of that angle over sine of 49. And I get about 3.2. So that is my second, what was that, 3.2. That's my second possibility for the third side. So I get two triangles here. The first triangle solution's denoted with the subscript of 1 and the second with the subscript of 2.